convolution properties. So we've talked about so far math. We're going to talk about properties right now. The convolutional properties, commutative, I'm abbreviating it, X. Here's another abbreviation. I could write X of n convolved with H of n is equal to, commutative would be H of n convolved with 8x of n. But just to speed things up a little bit, I'm going to write it like this. Okay, so you understand that x and h are not single variables. They're a function of n. I'm speeding it up because some of these other things get kind of difficult to describe without it. If we say, if y of n, let's say y of n was equal to x convolved with h, which is the same as h convolved with x. If y is equal to x convolved with h1 convolved with h2, then instead you could say it's equal to x convolved with h1 first convolved with h2. In a box diagram, we would say we have an x of n going into h1 of n going into h2 of n. If we know we have a system that does this, pre-compute our h1 convolved with h2, and then your system will run faster. Big deal when you're creating digital control systems for, say, planes that are inherently unstable, dogfighting planes, and you've got to have instant responses. The last is distributive. If you have a y that's equal to an x convolved with h1 plus h2, that's the same thing as saying x convolved with h1 plus x convolved with h2. On the left, that's like saying we've got an x of n that's going into our h1 of n plus h2 of n, and that is the, going to our y of n, and that's, by the distributive property, that's the same thing as feeding this x of n into, breaking it apart, and feeding it into an h1 of n and an h2 of n, which are then added at the outputs to form y of n. If you can figure out how to break apart operations to do this for a generic function, you will be a multi-billionaire. So if you look carefully, what's going on here is we're breaking things from serial processing to parallel processing. And if there's a way that you can find for a generic function, a generic algorithm ways to do this, to go from here to here, you can truly create the system of a future with a 1,000-core PC, each core running at 1 gigahertz that now is performing like a 1 terahertz clock computer.